expressions part 2. These are going to get to be a little bit more challenging because we have to go back to our factor rules that we learned in this class. So example E, we want to take x squared minus 25 over x minus 5. The most common mistake I see students make in this course is they want to go ahead and cancel out this 25 and 5 by 5, or they want to cancel this x and this x out by an x. You cannot do that. There is a subtraction sign between these terms, or not multiplier between terms. So we have to do factor, factor, factor first. So let's look at the first numerator of x squared minus 25. Remember, x squared minus 25 is the difference of 2 squared. So you can write this as x minus 5 and then x plus 5. That's the difference of 2 squareds. So what I'm going to do is go back over to my problem. I'm going to rewrite that x squared minus 25 as x minus 5 and x plus 5. Then in the denominator, it just stays as it is. It's just x minus 5. Now we're looking to see what factor cancels out. There is a common factor. This x minus 5 and that x minus 5 cancel out. So we're left with x plus 5 in the numerator over 1. There's your answer. We're going to ask you to do one other thing in this problem. We're going to ask you for what we call a domain restriction. When you have a fraction, in this case a rational expression, and the denominator equals 0, we call this undefined. So we're going to look back at this piece right here. What would make that whole thing a 0? If I substitute a 5 in for x, 5 minus 5 is 0. So the domain restriction is x can't be 5. If I substitute 5 in for x, that denominator would be 0, which makes it undefined. Here's our second example. Now we have a trinomial over a trinomial, and we want to factor it. Both of these are the same method of factoring, using our t-chart. So if you're not comfortable with factoring in your head with the t-chart, just do it off to the side. What are the factors of 5 that add to 6? And we list off the different multipliers of 5. So 5 times 1, or 3 times 2. And which one adds to 6? 5 plus 1 is 6. 3 plus 2 is 5. So the one that adds to 6 is this one right here. So those are the numbers we're going to work with. So we split up our x squared as x and x. And then we have plus 5 and plus 1. If we take those two green binomials and FOIL them back out, we'd be originally back to our trinomial. All right, let's go down to the denominator now. We're going to factor this polynomial. And it's a trinomial. We want to say, what are the factors of negative 2 that add to negative 1? So factors of negative 2 that add to negative 1. Well, negative 2 times positive 1 adds to negative 1. So those are the numbers we're going to work with. We split up our x and our negative 2, and our plus 1. Now, once we have it factored, we're looking for a common factor that we can cancel. The two that cancel are this x plus 1 and this x plus 1. So we're left with x plus 5 over x minus 2. That's my answer, but I can't forget about my domain restriction. Domain restriction is when we substitute a value in for x and it makes the denominator 0 or undefined. So what are the numbers that would make this undefined? So we're going to go back to the factored pieces in the denominator. If I substitute 2 into here, 2 minus 2 would be 0, which makes that whole thing undefined. So that would be a restriction. Then I come to this piece. If I substitute a negative 1 into right here, that would make it also a 0. So my domain restriction is x cannot be 2 or negative 1. Here's our last example. We want to factor the numerator. So the numerator can be factored using the difference of two squares. So it's x minus 6 and x plus 6. The denominator, we can't factor. It's just 6 minus x. Now we look for a common factor. There really isn't a common factor yet. But look at the denominator. It has a 6 minus x. So I'm going to leave that blue numerator alone. And let's just talk about flip-flopping the order of the denominator. So now it's negative x plus 6. So we're getting there. We're trying to look for that common factor. If I take a negative 1 out of the denominator, it'll work. So I'm going to leave the numerator alone again, the blue pieces alone, and I'm going to take out a negative 1 from the denominator. What I'm left with now is a positive x and a negative 6. Now do you see a common factor? There's a common factor with x minus 6 and x minus 6. So what we're left with is x plus 6 over negative 1. That looks kind of goofy to have a negative 1 in the denominator. So what you can do is you can rewrite it as negative 1 x plus 6. Or if you want to distribute that negative 1, it'll be negative x minus 6. Now that's your answer, but now let's go back and talk about the domain restriction. Is there a domain restriction here? Yes. If I go back right here, if I substitute a 6 into that place, 6 minus 6 is 0. So you cannot have a value of 6. So the domain restriction, I'm just going to call it DR for short, is x cannot be